Hello, ladies and gentlemen, and welcome back to the 2000 Pascal paper. Sorry. We're up to question number 20 now. So how about we take a look at question 20, and then we'll be done part B. All right. So, a straight line is drawn across an 8x8 checkerboard. What is the greatest number of 1x1 squares through which this line could pass? Now, I know occasionally I mention bringing props to a contest. I don't think a full-fledged checkerboard will fly, but you never know. So, it's always a good idea to instead draw a copy of a checkerboard for us. So, I will draw a big square, and since it's a checkerboard, which has 8 sides, or eight spaces on each side, I can use the very special division way of drawing this thing so it looks nice. So I'll draw a window and then divide each of those into smaller windows. And then divide each of those into smaller windows still. Okay, so we have an 8x8 checkerboard. And what is the greatest number of 1x1 squares through which this line could pass? It's a straight line. All right. So I kind of wish I hadn't drawn the 8x8 checkerboard because I can't immediately think of a way to approach this. But when I can't think of something to do with an 8x8 checkerboard, I could draw a smaller checkerboard, a smaller case, and examine that. So let's draw some lines on this checkerboard. So we could have there and it sort of just crosses, or we're going to have something like this, which crosses 1, 2, 3, or maybe something cutting across like that. Also gives us 3. So it looks like 3 is good. I don't think I can get a 4th one. Say I hit 1, 2, 3. I don't think I can hit this 4th one right here because I'm pretty sure if I just cross the diagonal here that it only counts as 2. So three is the best, and we measure that sort of empirically. We can't figure out a way to get 4. And now let's try a step up. Let's try a 3x3. So there's a line that just crosses 1. That's not very interesting. This line here crosses 2 of them. I can see right away I can get 3 of them. How about 1, 2, 3, and we'll say that just covers, so that's 4. How about 5? 1, 2, 3, 4, 5. Okay, so 5 of them. Can I do any better than 5? So I need to get 3 in the line, and then, well, actually no, I don't have 3 in the line. I sort of have 1, 2, 3, 4, 5. I don't think I can do any better than that. I'm pretty sure 5 is the best. And if I wanted to, I could go up to a 4x4 or even a 5x5, but I think, based on looking exactly what lines do what, should be clear. I think on the 4x4, the best we're going to get is a 7, so let's see if we can find a 7. Starting down here in the bottom corner is pretty good. 1, 2, 3, 4, 5, 6, 7. I think that's as good as we can get. So on an n-by-n checkerboard, 2n minus, no, it's 2n minus 1 is best. So for n equals 8, we'll have 15. So I think 15 is our final answer, but is there a way we can math this up a bit more, be a little more secure in what we're doing? So the line crossing the checkerboard is obviously got to enter on one side and exit on another side. Okay. If it's moving along and it crosses not at a point, or actually if it crosses any one particular line, we have entered a new square. So 1 cross, 2 cross, 3 and 4, 5 and 6. Okay. So 6 crosses means 7 because we start at one of them. All right. So how did we get these? Well, started in one square, because obviously we have to enter a square. And then, so we were able to get 1, 2, 3 of the vertical lines and 1, 2, 3 of the horizontal lines. And there are no other lines we can pass. I mean, if we cross one of these, one of the side lines, sure, but we're not entering in a new. We're not entering into a new square. So our reasoning here is we enter a square, and so that's one square. And so to enter a new square, we must cross one of the interior horizontal or vertical lines. There's n minus 1 of each of them. So there's 3 interior vertical lines, 3 interior horizontal lines in the 4x4 case. So 1 square plus n minus 1 for each of the possible horizontal or vertical lines. And that's 2n minus 2 plus 1, which is 2n minus 1. So not only were we able to come up with a pattern, we were able to sort of prove it or give a little bit of a reasoning as to why 15 is the best we're going to do. There's no way to get 16 because we'd have to cross one of these interior lines twice, and that would mean we sort of loop back or we're not a straight line. Okay. So I think that's good reasoning, and let's see where 15 is. It's E. So our final answer is going to be E. And we'll flip to the next page in anticipation of question 21, the first question in part C. But we'll take a look at that in the next video. Thank you guys so much for watching, and I'll see you next time.